Hi, hello everyone. Let's start discussion on the next video, that is a random variables distribution and expectation in the market risk analysis. So in this video, we will discuss on the fundamental of random variables and the probability theory and the expectations of it. We will discuss the fundamental concepts in the probability and the statistics, how it will work. Before start to the videos, I'll request you, if you are interested in the quantitative analyst role or the business analyst role or the quantum computing or the AI ML techniques, so please like and subscribe my channel, so that's motivate me to create and more such videos for you and help you to understand these topics in detail and to get the new jobs in the upcoming industries. So let's start with the videos. So we will first discuss on the fundamental of random variables. So how the random variable will work and what are the fundamentals of it. So let's first discuss on the introduction to the random variable, where we discuss definition and role of the random variable. There is the two types of random variable. One is a discrete random variable and another one is a continuous random variable, and how that random variable are importance in the finance. So let's start discussion on that topic. So, a random variable is a fundamental concept in probability and statistics. It representing a numerical outcome of random phenomena. It's generate the random numbers by using the rand functions or in the Excel or the np dot random function in the Python. So, in the context of market risks and the quantitative finance, random variable are used to model uncertain outcomes such as asset return, interest rate, or the credit default, or the derivative price, all the price of the stock that is and the uncertain, we don't know what are the price. So in that case we use the random variable with you feeding the different the variables and predict the price of that thing. So these variable allow analysts to quantify and manage the inherent uncertainty in financial market. Random variable can be broadly categorized in two types. So which first one is a discrete random variable and another one is a continuous random variable. So the discrete random variable take a countable number of distinct values and a different value, like the weight of the the peoples, or the number of male, number of female, so that's way. And such has a number of default in credit folios. And the continuous random variable on the other hand can assume any value within the range, such as the return on the stock over a period. Understanding the nature and behavior of random variable is essential for building the robust risk models and for the performing the accurate statistical analysis in the financial applications. So that's the importance of the random variable. So let's move on the next slide, where we discuss the discrete versus the continuous random variable. So where we discuss the discrete random variable, continuous random variable, and the statistical functions of it. So the random variable can classified in two discrete and continuous type based on the nature of their possible outcomes. So what are the outcomes that variable will generate? On that basis we will differentiate it is an the continuous variable or it is an the random variable. So discrete random variable take a specific countable values. Example include the number of defaults in a loan portfolio, or the number of trade executed in a day, how much the trade is default executed on a day, or how much the trade will done in that day. So that's we calculated in the discrete random variable. And these are typically modeling using the distribution such as the binomial and the Poisson distribution. So while we are doing the discrete random variable, we use the distribution such as the binomial and the Poisson distribution. And other hand, the continuous random variable in a contract can be take in any value within the continuous range. Example, the including the asset price, interest rate, or the return on which are often model using the continuous distribution like the normal or exponential distribution. So the continuous variable we use the normal and the exponential distribution, and the discrete variable we use the binomial and the Poisson distribution. So The distribution between the discrete and the continuous variable is crucial in selecting the appropriate statistical tool in modeling. So it is and the important to understand the what types of the variable and then select the exact distribution for that variable. For instance, the probability mass function MF, PMF and used for the discrete variable, while the probability density function PDF, probability density function PDF, is used for the continuous variable. So there are the two types of the function. One is a probability mass function and the probability density functions. Okay, understanding these difference helps in accurately modeling the financial phenomena and in applying the correct mathematical technique to do the analysis or to do the predictions in the future. So that's the difference between the random and the continuous variable. So let's discuss on the next slide, that is a probability distribution. So let's start discussion on this. Over the probability distribution, we will study that the role of probability distribution, common distribution types, what are the distribution types, and then parameter and the characteristics of distribution, and applying in the financial mathematics, how to modeling to apply these things. So the probability distribution describe how the value of random variable are distributed in different variable. They provide a mathematical function that assign a probability to each possible outcome of the variable. In a financial modeling, understanding the appropriate distribution to use a critical for accurate risk assessment and decision making while we are taking the financial decision. Is the important. Common probability distribution include the binomial distribution, and the Poisson distribution or the discrete random variable. So which model the number of success in a fixed number of independent trial. The Poisson distribution, which model the number of events occurring in a finance fixed interval of the time and or the space. And the normal distribution, which is widely used due to the central limit theorem. So we'll use the concept of central limit theorem, and it is a Bale-safe curve and the exponential distribution often used to model the time between event and the in the Poisson processes. Each distribution has its own characteristics and parameters, so we need to understand advantage and disadvantage of each distribution, such as mean and variance, which influence the shape and spread of the distribution. Selecting the right distribution involve the understanding the nature of data and underlying assumption of the models, how the model will work, and what are the assumptions we are considering while we are creating that model. So that's and the very important part for that. So let's move on the next slide, that is the expectations and its properties. So what are the properties and what are the expectation from each model? So expectation and expected value. So here we discuss the definition of expected value, calculate a discrete variable, calculation for the continuous variable, and application and limitation. So expectations and expected value of random variable is measure of a central tendency representing the average outcome of experimental where the repeated many times. For a discrete random variable, the expected value is calculated as the same of a product of each possible value and its corresponding probability. So expected value of x is the sum of expected value of probability of x. For a continuous random variable, it is a calculated using a interval of expected value of x to the integral of x into f of x into dx, where f of x is a probability density function. So understand. And the expected value is a foundational concept in probability theory and is extensively used in a financial modeling to estimate the average return, risk assess, and make investment decision. It provides a single summary measure that capture the central of distribution, making it easier to compare the different random variable or investment opportunity. However, it is important to note that the expected value does not convey information about the variable or the risk associated with the outcome. So that's the expected value. So let's move on the next slide. That is the property of expectation. So linearity of expectations, additivity property, product and expectation for independence variable, and applications in the portfolio theory. So that's the points. So expectation has an several important mathematical properties that make it powerful tool in statistics and financial analysis. One key property is linearity for any constant a and b, and the random variable x is the expectation of ax plus b is given by the expectation of x plus b is equal to the expectation of ex plus b. This property allow for straightforward manipulation of the expectation value in linear combination. And another important property is additivity. For two variable x and y, it is the expectation of x plus expectation y is equal to expectation of x plus expectation of y, regardless of any whether x and y are independent or any value of x and y. So when x and y are independent, the expectation of their product is the product of their expectation. So let's expectation of xy is equal to expectation of x into expectation of y. These properties are particularly useful in the portfolio theory, where the expected return of portfolio is weighted sum of the expected return of individual portfolio. And understanding and applying these properties is enable analysis to simplify the complex problem and derivative into the meaningful insights for the probabilistic models, how these models will work. So let's discuss on the applications in the risk management of these random variable or the discrete variable or the probability theory. So in detail, so application in the market risk. So modeling the financial variable, use the probability distribution, risk matrix and expectation, and trace testing and scenario analysis while we are doing these things. So in the field of market risk, the concept of random variable distribution, expectation, and are the foundational for modeling and managing the financial uncertainty. So asset return, interest rate, and other financial variable are model as random variable to capture their inherent unpredictability. The probability distribution are used to describe the behavior of these variable, allowing analysts to estimate the likelihood of various outcomes. For example, the normal distribution is often used to model asset return, while the Poisson distribution may be used to model the frequency of rare events such as the default, and the expectation is used to calculate key risk metrics such as the expected return or the investment or the expected loss in a credit portfolio. So these concepts are also integrated to calculate of value at risk, expected shortfall, which are standard measure of the market risk. So that's, we use to do the historical method, or the Monte Carlo simulation techniques or the parametric techniques to do the calculation of value at risk and expected shortfall. So additionally, they are used in stress testing and scenario analysis to evaluate the impact of extreme market condition, and mastery of these statistical tools is essential for any quantitative analyst working in the market risk domain. So you should understand that thing while we are working, you are working on the market risk domain. So let's conclude and discuss on the conclusion from this video. So summary and the key takeaway from these videos. So role of random variable, importance of probability distribution, expectation in risk evaluation, and advanced risk modeling. So in a summary, random variable, probability distribution, and expectation are crucial concepts of quantitative analysis in the market risk. So random variable provide a framework for modeling uncertainty, while distribution district the like of different outcomes. So expectation obtain a measure of central tendency that is essential for evaluating the average outcome and making the informed financial decision. So these concepts underpin many advanced risk modeling technique including the estimation of value at risk, expected shortfall, and scenario analysis. A solid understanding of these foundational topic enable the analysis to build a robust model and interpret the financial data accurately and contribute effectively to risk management strategy. As the financial landscape continues to involve, the ability to apply these statistical tools and remain the key competency for the market risk professional. So these are the techniques while you are working in the market risk domain as a quantitative analyst, so you should be apply. So guys, that is the end of this video. If you like my teaching styles and the concept and the topic which I am covering in the in these videos, so please do like and subscribe my channel, so that will motivate me to create and more such videos for you and help you to become the quantitative market risk analyst role. So once again, thank you so much guys, and please do like and subscribe my channel. Thanks.